Hello audience. Today in this video I am going to talk about a big data project, that is bank loan case study. To perform the data analysis on this particular project, we are given two data, that is loan application data and previous loans data. Coming to the description of this project, any financial company or bank offers a variety of financial services including loans, and the success of this business depends on the loan portfolio being sound. Any bank working on a data analysis initiative to assess loan risk in order to improve the risk management and decision making. The primary goal of this study is to find the pattern that indicates if customer will be unable to pay their installments. This information can be used to make decisions such as refusing the loan, lowering the amount of loan, or lending to risky applicants at a higher interest rate. The objective of this project is to develop predictive models to assess the risk associated with granting loans to customers, identify and mitigate potential credit and financial risk. The third objective of this project is improve loan approval process and policy based on data-driven insights, enhance the overall financial stability and profitability of the bank. There could be many challenges for this. The main challenge is that customers with insufficient credit history may take advantage of this and defaults on their loans. Our job is to perform EDA to identify trends in the data and ensure that qualified candidates are not dismissed. What could be the risk? The bank provides many risk assessment in their framework. The steps could be risk identification, risk assessment, risk quantification, risk mitigation, and then risk monitoring. The approach I have taken to perform data analysis in this project: first I collected the data, then data pre-processing, then exploratory data analysis. In exploratory data analysis, we have done the insights on loan applicants trend, customer behavior, correlation analysis, statistical summary, and factors affecting loan defaults. The expected outcome should be the improved risk assessment, data-driven decision making, reduced loan defaults, and competitive advantage. The tech stacks I used is Microsoft Excel 2021 on Windows 10 machine. The use of Microsoft Excel 2021 is very much required because of the following benefits. It has new features and functions, enhanced data analysis features, improved collaboration, better integration, performance improvement, enhanced security, user interface enhancement, compatibility with different devices, mobile and cloud integration, bugs fixes, and stability compared to the previous version. Now coming to the data description, there are two data sets. Dataset 1 is application data. In that, around 50,000 rows and 122 columns has been given. And in dataset 2, that is previous application dataset, in this dataset also 50,000 row and around 37 column is there. But while performing the missing value assessment, the missing data column is around 50, and in previous application data, missing data column is around 15. Now coming to the insights that we have got while analysis of this data, most of the applicants have no problem regarding the loan payment. Working category applicants have more problems in loan payment. Cash loans given more as compared to the revolving loans. The defaulters of cash loans are higher than the revolving loans. Applicants with laborer occupation is more prone to defaults on loans. To support these insights, we have performed some analysis, and the analysis has been shown in this table. Now coming to the task. The task 1 was to identify missing data and deal with it properly. To perform this task, I have done in following steps. Counted all the blanks in each column in the given data, then divided all the blank counts by the total number of row in the given data and converted it into the percentage. Using conditional formatting, change the color of those columns having blanks. All those columns with more than 30% blank have been deleted. Rest all blanks have been imputed with mean, median, mode value of the column. Here I want to mention that mean and median has been utilized for numerical continuous data, but mode is utilized for the categorical data. After removing the columns, the column number has been reduced from 122 to 73 in loan application data, and in previous application data the rows has been reduced from 50,000 to 49,667. Now to support this result, I would like to go to the Excel sheet. This is our application data that has been given. The total number of rows is 40,000. Now if you see, here we have 65% of data missing, and in the column occupation type 31% of data is missing. Similarly, we have performed on other column, and with this data we have got this proportion value, and the display of this blank proportion has been shown in the chart. The same chart I have described in the report. Now how we have handled the missing value? See, after deleting all the missing data, after imputing all the missing data, now we have currently 73 rows, 73 columns and 49,667 rows. Now this is what we have shown in the insights of the data. Now the task 2 is identify the outliers of the data set. Before performing this task, let me discuss about the outliers. Outliers are those data points that doesn't belong actually to the data and that may bias our data and perform badly on the model, predictive model. To calculate the outliers, we have the formula that we perform interquartile range, and that interquartile range has formula that is the quarter 3 minus quarter 1, that is the interquartile range. After getting the interquartile range value, we can say that all those data points which is lesser than the quartile 1 minus 1.5 of QR will belongs to the outlier, and all those value which is greater than the quartile 3 plus 1.5 IQR will be also the outlier. Now coming to the categorical data, we cannot perform this formula on categorical data. We have to go for whisker plot, or we can get the outliers through scatter chart. But for the continuous data, we can perform using the same formula. Here we have drawn many charts like scatter charts and whisker box plot chart on the data we have performed. I can show you on the Excel itself here. It is loading. See, see the children count of the applicants. One customer is having 11 children. That cannot be possible in this modern era. That definitely will be the typo error, or it belongs to the outlier. Some applicants one of applicants is having 9 children, one is having 8 children. That definitely belongs to the outlier. Coming to the amount annuity, some value belongs to more than 2,50,000. That is also outlier category. Similarly, we have performed outlier on the all data column that has been given. Here we can see one more outlier here in flag document 10. That means document 10 has been submitted or not. Many of the applicants have not submitted, but one of the applicants has submitted. That also definitely a outlier. Now coming to the third task. Third task was to analyze the data imbalance. Data imbalance is performed on the target column only, because we want to know that how much data it belongs to which classes, so that it should not be the bias while using the machine learning model or any predictive model. So after analyzing, we found that the 8% of the applicants having problem with payment of the loan, but 92% of the applicants are paying the loan on the time. Now coming to the univariate, segmented univariate and bivariate analysis. This table shows the univariate analysis of total income, amount of credit, amount annuity, and goods price. This is the statistical description. It is showing here. I can show you on the see. This is what we have performed on the Excel sheet for the mean, standard deviation, median on these four data column. Because this was the continuous column, so we have performed on this column only. Now coming to the more descriptive part, here is the chart for total income of loan applicants. Now we have done the segmented univariate analysis. We have divided the data into class 0 category and class 1 category. Class 1 category, that is the applicants having problem with loan payment, and we have the total applicants, and the beans of the total income range has been created. Here I have created the range and the total applicants, class 0, class 1, and the same has been shown in the data in the chart. Now same has been performed with amount of the credit, range, total, and how many belongs to class 0 and how many belongs to class 1. Similarly has been done with amount of annuity, total, range, and amounts of goods prices range. Chart has been created for the segmented univariate analysis. Now coming to the bivariate analysis, what we have done here is that we have created the range for income beans has been created, and for each income beans how much amount of credit has been approved. Here we can see that the income beans between 10 lakh to 11 lakh, 10 lakh to 10 lakh 50,000 is having higher range of credit amount approved by the bank. To show more knowledge, I have implemented slicer. It can perform on filtering and all those data. Same slicer has been created for bivariate analysis also. Coming to other part, that is correlation analysis. Correlation is performed on data to find the dependency or relation between two data columns. Here we can see that the four data column is more dependent on each other. The first is total income, amount of credit, amount of annuity, and amount of goods prices, and count of family members also dependent on the children count. And in both the category class 1 and class 0, we are finding the same type of correlation between the four columns. Now same thing has been performed on the previous application data. Here also missing value proportion has been shown. The same concept has been applied. After missing value handling, we got this data, that cleaned data and imputed data. After that, we perform the same outlier detection. Here we have amount annuity. Some amount is near to 2,50,000. Some amount is more than 2 lakh. And in amount credit, one data point is more than 40 lakh. So that is definitely outlier in the data. Amounts of good prices, some point is closer to 40 lakh. Now coming to the univariate analysis in the previous application data, we have the contract status, that approved loan is higher in frequency, and the client type, whether it is repeater or new client or refreshed, the repeater is having more frequency. And in the name payment type, the cash through bank. So many of the applicants want to get the loan by cash itself. Now coming to the bivariate analysis. In bivariate analysis, what I have done, I have taken the contract type and the customer type, customer's business on which they are performing business performance. So here we can see that the customer electronics is having more approved loans, and the applicants had which poses a repeater client type. With this, the repeater's loan has been approved frequently. Similarly, coming to the correlation analysis, the same four column, the amount annuity, amount of applicants, amount of credit, and amount of goods prices is having the higher correlation among them. Now all the analyzed data, the Excel sheet has been provided here in the Google Drive link, and the full project file also has been provided here. Thank you. You can ask me any doubt on my given email ID. Thank you guys.